7.2 common factoring. So what is factoring? Okay, to factor is to express a number as the product of two or more numbers. Okay, to express an algebraic expression as the product of two or more algebraic expressions. Okay, so number or expressions. So same applies when we like put maybe like those binomials together, maybe like x plus 2. Okay, and factoring is the opposite of expanding. Some polynomials can be factored by finding the greatest common factor. Okay, not all, but that's what we're going to focus on. That's like the first step of factoring. So we'll focus on that today. And the greatest common factor for a polynomial may be, okay, it may be a constant, so just a number, a variable, so just like a letter, or both. Okay, if the area of a rectangle is given as a polynomial, factor the polynomial to find the possible side lengths of the rectangle, and this one is going to be like the final example that we do today. Okay, so when we say expanding and factoring and how they're opposites of one another, okay, expanding is the process of like distributing in order to make your expression to fully expanded form. Okay, so that's multiplying. And now factoring is going backwards. Like here we'd factor out the 5, right? For 5x plus 35, it's dividing. This is backwards. So example 1, we're going to find the greatest common factor of each set of terms. So between 6x and 24, okay, so 24 doesn't have an x on it, so it's not going to include the x. Okay, but 6 and 24 both divide by 6, so the greatest common factor is just 6. That one's an easy one because at least one of these terms involves that 6, so it works. Okay, for 10 and 15, I would actually list the factors of 10. So 1 times 10, maybe 2 times 5. And I'd also list the factors of 15. Okay, 1 and 15, 3 and 5. So the common one is 5, so that's good, 5. And in order to be a common factor for the x's, we're going to choose the smaller exponent. Okay, so for the variables, the greatest common factor is the one with the smallest exponent. Okay, so between x squared and x to the 1 is going to be x. Okay, now see, the factors of 6 are 1 and 6, 2 and 3. 12 is 1, 12, 2, 6, 3, 4. 18 is 1, 18, 2, 9, 3, 6. Okay, so when I'm looking at these three, I see that the 6 is common. And now we have to take a look at the variables. We have an x in all of these, so it is common. Now the rule, choose the variable with the smallest exponent. We have a variable with an exponent 3, 2, and then 1. So I'm going to just pick an x. So our greatest common factor there is 6x. And now the last one, 3 and 5. 3 and 5 are both prime numbers, so we can't divide anything other than 1. So 1, I guess you can put here. And then we have x squared and then x. So again, the rule, choose the x with the smaller exponent. So 1x is the greatest common factor there. Okay, so for example 2, find the greatest common factor, then write the binomial in factored form. Check your answer by expanding. Okay, the greatest common factor between 10x and negative 15 is just going to be 5. So we're going to divide both of these by 5, and then we write the 5 out front, and after dividing, we write what's left over inside the bracket. So we're left with 2x minus 3. Okay, if we need to check our answer, we would take that factored form and we would expand this 5 into the bracket, and we would have 5 times 2x and 5 times negative 3. These are the same, so our answer is correct. Okay, for B, a common factor between 20 and 12. Okay, if you want to list the factors of 20, 120, 210, not 3, 4, 5. And then if you want to list the factors of 12, we can have 112, 2, 6, 3, 4. So the greatest common one here is the 4. So we're going to divide both of these by 4. And then we have x to the 1 and x squared. So we're going to divide both of them by x as well. Okay, so 20 divided by 4 is just 5. X and x cancel. 12 divided by 4 is 3. X squared divided by x is just x. Okay, and if we wanted to check, and I'll write this in a different color, we would take our factored form and we would distribute it back into the bracket. So 4x times 5, we get 20x, which is correct. And 4x times negative 3x, I get negative 12x squared, which is correct. Okay, last one. Factor negative 3x squared plus 12x. Well, in my head, I'm like, okay, negative 3x squared. 3 is a prime number, so the biggest number that we can pull out is the 3. And we are going to do that because 12 divides by 3. Okay, and then x squared and x to the 1, we're going to pull out an x. So we get negative 3x bracket. Those negative 3's cancel, and x squared divided by x goes down to just 1x. 12 divided by negative 3 is negative 4, and then x to the 1 divided by x just cancels. Okay, and that's our answer. If we wanted to check, we would get negative 3x, and we would distribute it back into the bracket. So, negative 3x times x, I get negative 3x squared, which is correct, and negative 3x times negative 4, I get 12x, which is correct. Okay, so all of these expressions have two terms, which are called binomials. Example 3, factor 3x squared minus 9x plus 12 completely. Okay, this expression has three terms, which is a trinomial. We factor this one by taking a look at all three of these terms and seeing what we can pull out. Okay, so 1 times 3, 9, we have 1 times 9, 3 times 3, and for 12, the factors are 1 times 12, 2 times 6, 3 times 4. So looking at all of these, the common one is 3. So if we had 3x squared minus 9x plus 12, we're going to divide each of these terms by 3. But here's the thing. For x squared, x and nothing. So we don't know x is here. That means we cannot common factor out an x. So let's pull this 3 out to the front, and we're left with x squared. Negative 9 divided by 3 is negative 3. We'll just leave the x. And 12 divided by 3 is 4. Okay, example 4. The area of a rectangle can be given by this polynomial here. Okay, so we have a rectangle. We don't know its width or its length, but the area, usually we write that inside the rectangle, is 12x plus 3x squared. So, write expressions for its length and width by factoring. So, we have 12x plus 3x squared. I'm going to factor out a 3x. Right? X to the 1 is the lower exponent, and then 3 is a prime number, but 12 divides by 3, so we're going to choose that 3. So when we divide, we get 12 divided by 3, and those x's cancel. 3 divided by 3 cancels. X squared divided by x just goes to x. So maybe the length is 3x, and the width is 4 plus x. Okay, B says find the actual dimensions if x equals 6. So the length, and then we have an expression for the width. So if x equals 6, we're subbing that in. 3 times 6 is 18, and then 4 plus 6 is 10. And we can call this units. Okay. Determine an algebraic expression for the perimeter. So perimeter is when we go all the way around the object. So we're going to go 3x plus 4 plus x plus 3x plus 4 plus x. And we're going to add all of these together. So 3, 1, 3, and 1. We get 8 x's. And then 4 plus 4 is plus 8. So here's a simplified expression for the perimeter. Okay, now D wants us to find the perimeter using the actual dimensions. So if, for example, we had 18 and 10, okay, it doesn't matter where those go, right? Length and width are interchangeable. We would have perimeter is 10 plus 18, okay, plus 10 plus 18. And we would get 20, 30, 40, 50, 56 units. Or we can use this expression and actually check if our answer is correct. So I get 48 plus 8, which is 56. Okay, as you can see, both of these, we get the exact same answer.